Good evening, everyone. Welcome to Byju's Exam Prep IAS. Today, we are going to start with our seventh session on science and technology. And here we are going to continue from where we left yesterday. But before we begin, first thing, a quick check if audio and video both are working fine. Please let me know. Good. Wonderful. So today we are going to begin with our discussion on launchers. So we'll discuss about launchers, we'll discuss about ISRO as an organization, and there are some other miscellaneous topics that we'll discuss. So these are the areas that are left in this portion of our discussion in space technology. And then we'll also look at some of the questions that have come in the mains examination from this chapter. So we'll discuss all that and then we'll move on to our next chapter, that is biotechnology, towards the end of today's session. So let's begin. The first thing that we are going to discuss here is launchers. Now, until now, what we have come to know is that there are various applications of satellites and we launch the satellites. There are different orbits where the satellites are launched, and based on what kind of application we are launching the satellite for, we accordingly launch the satellite. We accordingly launch the satellite into a particular orbit. So we discussed all that. But to launch a satellite, we need a vehicle, which is called as the launch vehicle or the launcher. And there are different types of launchers depending on where are we going, depending on what orbit are we targeting. Depending on all that, we see that there are different types of launchers that we use. So as you can see on your screens, that there are all these launchers that India has used over the period of time. Now, when we look at all the launchers that we've used, there are three categories into which we can divide these launchers. First, you can say are the retired launchers or the historic launchers, the ones that we don't use anymore. And this is where we have SLV and ASLV. Then after that, we have the ones which are operational, the ones that we use today. And this is where we have PSLVs, GSLVs, sounding rockets, SSLV, and then GSLV Mark III, which is also called as LVM3. And then after that, when we look at the ones which are for the future or the ones which are under development right now, we have RLV, Scramjet, and NGLV. NGLV standing for Next Generation Launch Vehicle. So we'll discuss about all these launch vehicles one by one to try and understand what exactly they are, where do we launch the satellites with them, and what is their importance for India. To start with, we have the historic launchers where we have SLV and ASLV. Now, when it comes to SLV, SLV stands for Satellite Launch Vehicle. The very first launch vehicle that India had was SLV-3. Now, compare was not really a culture of nanosatellites as such. So, and this SLV-3 launch was back in 1979. So back then there were no nanosatellites. Now, when it comes to these launch vehicles, that's where experimentally they gave us an understanding of how to launch a satellite. So we understood that, and then after that we see that we improve upon that, and the next one that we had was something capable of launching 150 kgs class satellite called as ASLV, or Augmented Satellite Launch Vehicle. So augmented satellite launch vehicle was ASLV, and again this was operationally used back in 1992. So gave us a better, you can say, uh, capacity to launch the satellites, but yet not enough. Because when you look at the early launches that any country was doing, largely these were communication satellites. Largely communication satellites plus some of the Earth or some of the Earth observation satellites. So there were only these two types of satellites being launched back then, and largely also these were communication satellites. So India did not really have any launch vehicle where we could launch our own satellites. So we used to take help. We largely used to take help from France and use their launch vehicle to get our launches done. Now, After this, we come to an era where we are able to launch our own satellites. And this is where we have the very first one called as sounding rockets. Now, you might not have heard of sounding rockets. Do you know that there is even something called as sounding rockets? You might have heard of PSLVs, GSLVs, or maybe even SSLVs. But have you heard of sounding rockets? Do you know that there is something called as sounding rockets? So many of you don't. That's okay. I have seen sounding rocket launch. That's wonderful. So, so as I see that most of you haven't seen what sounding rockets are, then this is the news for you. In 2022 November, India completed RH-200, which is a sounding rocket. It had 200 consecutive successful flight. So there have been more than 200 successful launches of sounding rockets, which is more than what PSLVs have done and what GSLVs have done. And so we, compared to that, we have seen more launches with sounding rockets, yet we don't really hear a lot about sounding rockets. Why so? The reason is that most of the times the sounding rockets are used for experimentation, for experimental purposes. Many a times it would be just an atmospheric experiment, sometimes space or defense related experiments. So that's why these are not very significant. These are just tests. These are just experiments. So that's why you do not see or hear about them in the news. So that's why you don't really know a lot about them. So that's why when it comes to sounding rockets, understand why are they being even called as sounding rockets. So sounding doesn't come from the word sound. It's not related to something which is some kind of sound or some kind of noise. That's not the case. It's more of experiments. All right, it's more about experiments and how exactly the experiments are conducted. To sound is basically to test, to experiment. So that is why these are called as sounding rockets. And as you can see here, these are one or two stage solid propellant rockets. Now understand this also, one or two stage. When we say stage, the meaning of stage in a manner, you can say that these are nothing but the compartments of fuel. All right, these are nothing but compartments of fuel. So that's why what we call as, if we say that something is a two stage rocket, it means that there are two compartments of fuel that are filled in this rocket. Similarly, PSLV is a four stage rocket, meaning that there are four compartments of different fuel that we are using. So in, I mean, oversimplifying things, this is what it is. And then solid propellant. Propellant in a manner, we mean that propellant is nothing but, you can say, the fuel that we are using. So we are saying that here we are using solid fuel. What is solid fuel? Anything that is solid and being used as fuel. For example, coal. We don't use coal in these rockets, but coal can be called as a solid fuel. Petrol and diesel can be called as a liquid fuel, right? So this is how we can say propellant. So one or two stage solid propellant rocket, meaning that there are one or two compartments of fuel, and these basically uh, are used for probing the upper atmospheric regions for space research. And again, there have been different types of sounding rockets that we have used, but this is not really very important for you from examination perspective. I've just given you this data so that you can just see it once for your reference. That's it. Now, coming to probably the most important launch vehicle that India has, this is Polar Satellite Launch Vehicle, or PSLV. Now, where do we use PSLVs? From yesterday's information, tell me. I had given you some information about PSLVs. We discussed about something in the context of which we discussed about PSLVs. So, can you quickly tell me what kind of launches would we do with the help of PSLVs? Yes, Shimna, you are correct. Tirtha, you are correct. Prithvi, correct. Okay, so one thing I understand, many of you have written about this, which is correct, that it will be largely used for the low Earth orbit, but also for the medium Earth orbit. We can, all right. So, but largely low Earth orbit. Now, the second question is what kind of satellites? I also discussed something about the weight of the satellites. What related to the weight of satellites with regard to PSLVs? Lightweight. Perfect. So that's why remember two important things. One, that largely will be launching for low Earth orbit. See, it's not that we can't launch it for the other orbits. We can, I mean, for example, all the IRNSS satellites, they have been launched using PSLVs and they have gone to high Earth orbits. Aditya L1 has gone to L1 point, yet we have launched it with the help of PSLVs, but largely low Earth orbits. And secondly, lightweight satellites. Lightweight satellites. If you remember, we discussed less than 1500 kg is where PSLVs are very useful. So now in this particular scenario, when it comes to PSLVs become very very crucial. The first successful launch was done in October 1994, and ever since then we have seen that a lot of very very important launches that India has done, they've all been done with the help of PSLVs, and that's why they have been termed as the workhorse of ISRO. That's why they are called as workhorse of ISRO. So because a lot of different launches, whenever we have had a very important launch, we have first tried whether it is possible with PSLVs or not. If it is possible with PSLVs, we have always preferred PSLVs, and it has shown remarkable success. Remarkable success. The number of success, for example, between 2007 to 2017, there was not a single failure that was observed in a PSLV launch, which is extraordinary. None of the space agencies across the world can say that they have been able to achieve something like this. So that is the importance of PSLVs for India and for ISRO. So whether all the Earth observation satellites, all our IRNSS satellites, the Mangalyaan mission, the Chandrayaan 1 mission, then after that, the Astrosat mission, the Aditya L1 mission. So there are remarkable number of launches and versatile launches that have been done by PSLVs. And that's why PSLVs have been so important. And especially, there has been an instance where PSLV has been in the forefront of a global discussion, and this was at the time of the Mangalyaan mission. Now, during the time of Mangalyaan mission, there was a lot of negative campaigning that happened against India, and this is not something which is new for the Western media. You see today also, you'll see something very an approach which is very similar. You go back 10 years in time, 15 years in time, 30 years in time, you'll see that the approach is very similar. It's not that they have something against this government or that government. They in general have had an anti-India, or let's say anti-East kind of an approach. Anti-Asian countries, anti-African countries, the Western media, I mean, just being blunt, they can't see the success of any of the Asian or African countries. So that's why whenever something like this happens, there will be a lot of negative campaigning that they will always do. At the time of Mangalyaan, what was this negative campaigning? This negative campaigning was that, look, India is such a poor country. Is this a country that should even look at a launch to Mars? Why do they even want to go to Mars? First, feed your population. First, feed your population and then try to go to Mars. The money that you are wasting on going to Mars could have been utilized on feeding the poor. This was the logic. This was, and we see a lot of Western media doing this at that point of time. Not only this was one thing that, okay, they are saying that don't invest on space technology, invest on poverty alleviation schemes, etc. Now one thing here needs to be understood very well, that when we are spending money on defense, when we are spending money on space technology, when we are spending money on anything that is scientific or anything that is advanced research, it doesn't mean that it is wasting India's money. Today it is only because of space technology that we have been able to do much better in agriculture. We have been able to do much better with our disaster management. We have been able to do much better with our rural and urban developments. All these also largely have been attributed to the way space technology has played its role in all these aspects. So that's why one cannot say that space technology is where somebody is wasting money. And similarly, even if Mangalyaan mission, first and foremost, Mangalyaan mission has been the cheapest mission to Mars. The per kilometer cost of Mangalyaan mission is lesser than what you perhaps paid to an auto rickshaw per kilometer. So just imagine the kind of cost reduction that we are speaking of. Secondly, there was a negative campaigning on the basis of, is India trying to compete with us? Is it even worthy of competing with us? And in this context, there was this cartoon that was published by New York Times in 2014, where they are showing that there is an elite space club, and there is this person standing with the cow, and this is how they depict India, that if you have to show an Indian, show a cow. That's the easiest way to show that somebody is an Indian. So it's a plain and simple case of racism, and how they do not see the eastern countries at the same pedestal as the western countries. And this is what they were showing, that there is this person who's knocking on the door, and there is so-called elite space club, and India wants to join that elite space club. So this was very unfortunate that uh, so-called one of the biggest media houses in the world publishing this kind of a cartoon. This shows their insensitivity. This shows their respect for countries like India or China, Japan, African countries, whatever it is. They did apologize later, after it became a big issue, a big controversy. They did apologize, but do you even think that they meant that apology? Because if they had that kind of sensitivity, if they had that conscience, they would not have published. They would not have The editor would not have let this being published in the newspaper itself. But it did come up in the newspaper. But then there was a very fitting reply, and this reply was by Times of India in 2017. Now, in 2017, we launched PSLV C37. And this PSLV C37 made a world record. The record was that we launched 104 satellites in a single launch. 104 satellites in a single launch. So that was unique, no, not done by any country until now. The previous record, I think, was held by Russia with just 38 satellites in one single launch, and we defeated that by a margin by launching 104 satellites in one single launch. And this is when the Times of India, this was published in the Times of India, and they shown they here now they were showing that there is this elite space club where now India is sitting inside, and then there are all these elite people who are knocking the door. And why exactly this? Because out of these, very important, out of these 104 satellites that we launched, 101 were foreign satellites. There were 101 foreign satellites, and that too, out of this, 95 US based satellites. And only three Indian satellites. One was a Cartosat series satellite, and there were two INS satellites, ISRO nano satellites. So two Indian nano satellites, and then one Cartosat satellite. That's it. There were three Indian satellites and 101 foreign satellites in one single go. And the story is unique. Initially, the plan was only for 78 satellites. We wanted to launch 78 satellites, but then just how all our public transports work, that there always is room for something extra. So here also ISRO announced that there is room for extra. So if you have your satellite that you want to launch with this launch, we are here to help you. So just that how in a bus there is always that extra space, similarly in our launch vehicle also there was this extra space, and we were able to do this. So so that's why this was, I would say, a befitting reply, media to media, and was required. So PSLV, what is PSLV? It has four stages using solid and liquid propulsion systems. Now, PSLV, just understand the basic structure of a PSLV. A PSLV rocket would look something like this. So where we have four stages. See, ISRO takes almost 6 months to design one PSLV. I took 10 seconds. to design the same PSLV. So this is where you have your satellite. This is where you have your payload, right? You have the payload or the satellite here. And then after that, all the four stages that we have, all these four stages are alternatively arranged: solid, liquid, solid, and liquid. So the first stage is a solid stage, followed by a liquid stage, then a solid stage, then again a liquid stage. So this is how it is arranged. So the first stage carries 138 tons of hydroxyl terminated polybutadiene or HTPB. No need to remember the entire thing. HTPB is enough for you. And then after that, the maximum thrust that it can get is 4800 kilonewtons. Now again, all these information not important. The only thing that is important is that we are using HTPB as the fuel here. Then the second one is where we are using unsymmetrical dimethyl hydrazine or UDMH. UDMH. So this is a liquid fuel. This is a liquid propellant or a liquid fuel. Then in the third stage, we are again using HTPB. So this is where we are again using HTPB. That is a solid fuel. And then the fourth one is where we are using monomethyl hydrazine or MMH. So these are the four stages of a PSLV. So alternatively arranged at solid, and liquid stages. Now, when it comes to PSLVs, we see that there are all these different variants of PSLVs that we have used over time. Now, again, it's not really important that you know each and every one of these. That what is CA, what is G, what is XL, DL, QL, not required. But out of all these different variants that we have, most important variant I would say is PSLV XL, because PSLV XL has done majority of the crucial strategic launches for India. The very first launch, for example, of PSLV XL was this Chandrayaan 1. The very first launch was Chandrayaan 1. And if you look at the last launch that has been done with the help of PSLV XL, this was Aditya L1. This was Aditya L1. So that's why in this context, we see that many of the crucial launches, the most important launches that India has done, they've been done with the help of PSLV XL. So that's why PSLV XL remains one of the most important variants of launch vehicle that we have. Then the second launch vehicle, again a very, very important launch vehicle, is geosynchronous satellite launch vehicle. Now, geosynchronous satellite launch vehicle or GSLV. Now, when it comes to a GSLV, again, GSLV also has three stages. This time, sorry, just remember that GSLV has three stages, not four. PSLVs have four stages. GSLVs have three stages. So, when it comes to the three stages of GSLVs, again, you have the payload here. Payload basically is the satellite or everything that you are carrying, the instruments, etc., that you are carrying. Here again, the first stage is solid, which is again HTPB. Second stage is liquid, which is again UDMH. But this time there's a difference in the third stage. The third stage is cryogenic. The third stage is cryogenic. The third stage is cryogenic stage. So that's why these three stages, they become very crucial from the perspective of GSLV, and especially the role of the cryogenic fuel. So what we are using here is a cryogenic fuel. Now understand why cryogenic and what is cryogenic. Cryo. First, the term cryo. Wherever you see this term cryo, even in the context of geography, you might have heard of cryosphere. So, cryo is a term that we use for extremely low temperature. Extremely low temperature. Right? So, wherever we have very extreme temperature, very low temperature, the word cryo is used. So, when we say cryogenic fuel, cryogenic fuel is a fuel that is ignited at extremely low temperature. All right, very low temperature. So that is why it is called as cryogenic fuel. It is basically a mixture. It is a mixture of liquid hydrogen and liquid oxygen. Liquid hydrogen and liquid oxygen. And also understand why liquid oxygen and why liquid hydrogen. Here liquid hydrogen acts as the fuel and liquid oxygen acts as an oxidizer. Oh, oxidizer. So now, when it comes to a liquid propulsion system like this, what we understand is that when it comes to the geosynchronous satellite launch vehicle, it is something where we understand that this basically is being used. Now, when it comes to the use of cryogenics, the use of cryogenics have been very, very crucial for India because, sorry, what happened? Mhm. Hmm. Some problem with going back and forth. Yeah. Huh. So, Hmm. So what we are doing is that we are using cryogenic fuel. Now, when it comes to the GSLVs become very crucial, and why in this context we see that the use of cryogenics become crucial. Cryogenics is where you get a lot of thrust. The efficiency is also very high. The amount of thrust that it can generate is also uh, very, very uh, so the efficiency is also very, very high. Now, cryogenics, if you look at the countries that have cryogenics, you'll find that there are handful of countries. There are just handful of countries in the world which have cryogenics, which have developed a cryogenic technology. So that's why for India also to be along with these countries, it's very, very crucial, because when it comes to the cryogenic technology, it becomes extremely important from the perspective of India, that India has been able to develop this cryogenic technology on its own. And the entire thing about when it comes to geosynchronous satellite launch vehicles, it becomes crucial because uh, it has been a long story of getting cryogenic technology for India. So, for example, back in 1970s itself, India could have gotten hands to cryogenic technology, and France was ready to provide India with cryogenic technology, but it could not happen. But uh, uh, could not happen back then because there were certain uh, problems or that we were facing internally in India, and because there were so many projects that Indian scientists were working on, we thought that we do not really need cryogenic technology back then in 1970s. So which many also believe today that it was a strategic mistake. But when you look at the perspective of having cryogenics or not having cryogenics in 1970s, we did not have anything that could use cryogenics in 1970s. So that's why perhaps the scientists thought that right now our focus should be on something else rather than getting hands on cryogenics. But then it was a long journey from there on, because then in 1980s, I think 1986 87 was when a US based company was ready to sell cryogenic technology to India, but at a very high cost. And that's why India said that we can't afford to spend so much of money on cryogenics yet. So we did not get it. So 1970s we did not, 1980s we did not. Then USSR back then, which was about to become Russia at the end of Cold War, they gave us cryogenics for free. They were supplying cryogenic technology to India for free. But this is when US intervened and did not let that technology transfer happen, because there was something called as MTCR. There was something called as MTCR. Now, when it comes to MTCR, that is Missile Technology Control Regime, as a part of MTCR, an MTCR country, meaning a member country of MTCR, is not allowed to give a missile technology to a non-MTCR country. Now, both USSR and the US, they were a part of MTCR, and India was not a part of MTCR back then. Later, 2016, we became a part of MTCR, but 1989, 1990, we were not a part of MTCR. So Russia, according to the laws of MTCR, was not allowed to provide cryogenic technology to India, because cryogenic technology was also seen as a missile technology. It has been seen as a defense technology. Even if you go back to the early days, even 1950s and 40s, you'll find that there are countries who have been using cryogenic technology even back then. So that's why it's not something which is a new technology, something that we have developed or only recently has been developed. So that's why this is when we saw that this is obviously when US intervened, because US cannot see anyone else growing in the world. Anyone who tries to grow, US will always be after their life. And that is basically what happened here, that they did not want that India should have the access to this technology. And that's where, to when it came to the transfer of cryogenics from Russia to India, they intervened. They said that we will put sanctions on both Russia and India if this transfer happens. And the transfer could not happen. So then we realized that if we want to get hands to cryogenic technology, we perhaps will have to build it on our own. And this is what we started doing. And ultimately, we were able to crack the cryogenic technology. We were able to build the cryogenic technology. There were a couple of Russian engines that we had, Russian cryogenic engines that were there in India, because Russia was not allowed to give us the technology, but they could sell us the engine. So they had sold us the engines which were used in GSLV Mark 1. So in a manner, we reverse engineered, we also understood a lot of things. It is also said unofficially that Russia was still helping India behind the closed doors, but ultimately we did understand how to use cryogenic technology, and we were able to make cryogenic technology, which is basically a bunch of which is a mix of liquid hydrogen and liquid oxygen. So that is where we see that now we were able to get hands on this technology, which was very, very significant from the perspective of India's not only space technology, but also from the perspective of missile technology. So that's why we see that there are all these developments that ultimately led to GSLV Mark 3. And today we have three different variants of GSLV. One is GSLV Mark 1, Mark 2, and Mark 3. When Mark 1 and Mark 2, if you see, these are very similar, right? The height is same, lift off mass almost the same, number of stages almost the same, payload to low Earth orbit almost the same, and payload to geosynchronous transfer orbit is also the same. So Mark 1 and Mark 2 are very similar. Why? Because in Mark 1, we were basically using the engine, Russian cryogenic engine called as KVD-1, and then we developed our own cryogenic engine, the Indian version of cryogenic engine, which was Mark II, which was, you can say, more or less a replica of the Russian technology. And then later on, we developed GSLV Mark III, which is much superior version of what GSLV Mark 1 or Mark 2 have been. So you can see that all the parameters that we see in GSLV Mark 3 are pretty different. So that's why many a times now what we see is that ISRO says that we don't want to call GSLV Mark 3 as GSLV Mark 3, but rather we want to call it as LVM3. LVM3 standing for Launch Vehicle Mark 3. LVM3 standing for Launch Vehicle Mark 3. All right, standing for Launch Vehicle Mark 3. Now, so that's why they are saying that, look, all the parameters are pretty different. The kind of cryogenic technology that we are using here is also very different. So given that there are so many differences between Mark 1, Mark 2 versus Mark 3, we should not call it as another technology which is similar to the other GSLVs. So that's why they have started calling it as LVM3. So whether you come across GSLV Mark 3, whether you come across LVM3, both mean the same thing. There's no difference there. Where's the difference? If you look at the payload that they can carry, the payload carrying capacity of GSLV Mark 1 and Mark 2 were up to 2500 kg to GTO and 5000 kg to low Earth orbit. But when it comes to GSLV Mark 3, this is where 8000 kg is their low Earth orbit payload capacity and 4000 kg is their uh, payload capacity to geosynchronous transfer orbit. So that's why we see that this is basically where they have a lot of improvements. They have a lot of improvements, and that's why their capacity altogether have increased. So GSLV Mark 3 has been very, very crucial, especially when it comes to our communication satellites, because for launching the communication satellites, it's very essential that we have these heavier launch vehicles, and that's why this is where the cryogenics become very crucial. Read this question. This was asked in your paper. Pretty simple question, but please read it. I'm launching the poll. Please mark your answers. Very good. 73% of you have given the correct answer. So, which is A. So, let me discuss this with you. With reference to India's satellite launch vehicles, consider the following statements. The very first statement is PSLVs launch satellites useful for Earth resource monitoring. This is correct. Whereas GSLVs are designed mainly to launch communication satellites. This is also correct. So, first statement is fine. Second, satellites launched by PSLVs appear to remain permanently fixed in the same position in the sky, whereas when viewed from a particular location. Is that possible? It's not possible. Which is this orbit? This is the geostationary Earth orbit, where you launch satellites with the help of GSLVs. Correct? Because PSLVs are launching the satellites to the low Earth orbit, where you are completing one revolution in just 1.5 to 2 hours of time. That's it. Correct? So that's why in this context, this is a wrong statement. Third statement is GSLV Mark III is a four-stage launch vehicle with the first and the third stages using solid rocket motors and the second and the fourth stages using liquid rocket engines. Which is this launch vehicle that we are talking about? Is it GSLV 3, GSLV Mark III or something else? Which launch vehicle has been described here? Can you tell me? Yes, it is PSLV, right? This is not GSLV Mark III. What they are describing here is basically a PSLV. So that's why this is also wrong. So correct answer, that's why will be only one. Now, next, again, a very crucial part of India's space technology development has been this one engine called as the Vikas engine. Now, Vikas engine is used for liquid fuel. To support liquid fuel, this is the engine that is used for the liquid propellants that India is using in its PSLVs and GSLVs. Now, why Vikas engine is important? Because the stability with liquid propulsion systems has not been easy entirely for the world. Not It's not only a problem for India, but has been a problem globally. Then this is something that we got from France. France gave us the license for its Viking engine, and this Viking engine is what France uses for their liquid propulsion systems. So then France provided this licensed version of Viking became Vikas in India. So then Vikas, they basically named it after Vikram Sarabhai, and that's why Vikas engine was given as the name. Now, Vikas engine, surprisingly and interestingly, has been one of the best engines for liquid fuel in the world. Today, when we do the tests and the stability tests and the efficiency tests, it actually fares better than the Viking engine. So we took the license of the Viking engine and we created a better version of the Viking engine here in India. So that's why in this context, Vikas engine has been very, very crucial, because for launching our liquid, uh, sorry, for the liquid propulsion systems that we have in whatever launch vehicle, Vikas engine is what is used. Now then, after this, we also have now the small satellite launch vehicle. Now, small satellite launch vehicle, it's a three-stage launch vehicle where all the three stages are solid propulsion stages, but there is a module at the end called as the velocity trimming module, which is a liquid propulsion based module. Now, understand why. So, first, small satellite launch vehicle, meaning what? That we can launch small satellites with the help of this launch vehicle. Correct? So, that's why it is capable of launching the satellites which are less than 500 kg. Satellites which are less than 500 kg, and that's why we see that these are called as small satellite launch vehicle. Now, one thing very important, that all the three stages, as you can see, that there are three stages, and all the three stages are solid. But lastly, we have kept this velocity trimming module. So, what is this velocity trimming module? And as you can see, that this velocity trimming module, this has a liquid propulsion. This is based on liquid propulsion. Now, why exactly this? Because when it comes to uh, the solid fuel provides a lot of thrust, force. Right? It provides a lot of thrust or force, but controlling a solid fuel is not that easy. Compared to that, controlling a liquid fuel is far easier. All right, controlling a liquid fuel is far easier as compared to controlling a solid fuel. So that's why when you look at any launch vehicle, you'll find that last stage of the launch vehicle is never solid. The first stage probably always is solid. Why? Because solid fuel provides a lot of thrust, a lot more thrust than other fuels. So now when you are on the earth, when you are just launching the satellite, when you are just launching this rocket, the gravitational effect of the earth is very strong. Correct? Because you are on the earth itself, so you need a huge amount of force so that you can get out of the earth's sphere of influence. So for that you need the solid fuel. But towards the end, when control matters a lot more than the amount of force, when control matters a lot more, this is where liquid fuel or cryogenic fuel is preferred. So that's why even though this small satellite launch vehicle is a three-stage solid fuel vehicle, yet there is this velocity trimming module, which basically is based on liquid propulsion. So this, and why exactly do we need this VTM, or what is the role of this velocity trimming module? This velocity trimming module basically will help us in achieving the desired velocity that we need while inserting the satellite into the orbit. All right. So this is basically what we do. This helps us achieve. This helps us achieve the desired velocity for a satellite inserting a satellite into the required orbit. All right. So that's why velocity trimming module so becomes very, very crucial. Now, when it comes to SSLV, in the context of SSLV, it becomes very, very crucial because it is low cost, low turnaround time, flexibility in accommodating multiple satellites, launch on demand feasibility so that private launches can be done, minimal launch infrastructure requirement. So there are all these advantages that we have. Now, something which is very, very important, sorry, yeah, something which is very, very important in the context of small satellite launch vehicle is that ISRO is transferring SSLV to private sector. And there are 23 private companies that have been in the race for SSLV technology transfer from ISRO. Now, this is something which is very unique because until now, I don't know of any example in the world where a space agency would have created a launch vehicle and would have given it to the private industry. But ISRO is willing to do that because this is where we believe that this will lead to a better growth in the space sector, the private space sector in India. It will create more opportunities in the private space sector in India, and hence it will create a lot of employment opportunities, and a lot of startups, etc., will also start to grow around all these things. So that is basically, you can say, the rationale or the thought process behind transferring of these SSLV to a private company. So until now, what we see is that it is being maintained by NSIL, New Space India Limited. So NSIL is looking after all the operations and everything related to SSLV, but then from NSIL it will be given to a private company. A private company would take over. So that's why, from this perspective, this is crucial. Now, so this has been, you can say, in a manner, everything that is in the present. Now coming to the future. And when we look into the future, one of the most important technologies for the future has been scramjet. Now, when it comes to the scramjet technology, scramjet basically stands for supersonic combustion, supersonic combustion ramjet. All right, supersonic combustion ramjet. Now, ramjet basically is a kind of jet engine which is called as air breathing jet engine. Now, what we mean by air breathing jet engine, understand this. So, air breathing jet engine is that we discussed, if you remember, we discussed in cryogenics that we use liquid hydrogen as fuel and liquid oxygen as an oxidizer. Correct? This is what we discussed: liquid oxygen as an oxidizer and liquid hydrogen as fuel. Oxidizer. Understand the role of an oxidizer. What does an oxidizer do? Now, an oxidizer is very, very important because it supports combustion. Combustion cannot happen if there is no oxidizer. For example, even if you are trying to just light a matchstick, even if we are just trying to light a matchstick, you cannot light the matchstick if there was no oxygen in our atmosphere. In the absence of oxygen, in the absence of, let's say, anything that can act as oxygen, combustion wouldn't happen. Fire wouldn't be ignited at all. So oxidizer, that's why this is the role of an oxidizer. So oxidizer basically supports combustion. All right, uh, oxidizer would support combustion. So that's why we need an oxidizer. So here what we do is that in a lot of launch vehicles, we carry a huge amount of oxidizers along with the fuel, so that these oxidizers will keep on interacting with the fuel and help in the combustion of the fuel. But then it also increases the weight of the launch vehicle, right? Increases the weight of the launch vehicle. That also means that you have to use more fuel. Also, the carrying capacity of the launch vehicle also decreases. So there are a lot of these shortcomings, there are a lot of these problems that we face when it comes to the use of bulkier oxidizers, and this is one of the problems that we want to solve with scramjet. That instead of carrying oxidizers, we would carry we would not carry oxidizers, but rather use the atmospheric oxygen, the oxygen that is there in our atmosphere, that will be used as an oxidizer instead of carrying this oxidizer. So if you see this, how it works, that as this is the forward motion of the engine, and the air will be coming inside the engine like this. So this air is coming inside like this, and what happens is this air obviously has oxygen. So this air gets compressed and it gets heated up, and this hot air that we have, which has a lot of oxygen, gets in contact with the fuel, and then it leads to the combustion of the fuel. So that is exactly how a scramjet engine works. That hot air which is compressed comes in contact with the fuel, helps in the combustion of the fuel, and the forward motion of the engine so continues. Now, when it comes to this scramjet technology is not only something that is useful in the context of space technology or our launch vehicles, but they are also useful in our missiles. So, for example, you'll also read news about BrahMos missiles, that how we want to integrate scramjet with BrahMos missiles in the coming future. So that's why scramjet becomes a very, very crucial technology. And this is where you have to understand that why development of technology is so important. That something that is being developed for space technology in India is also useful for defense technology in India. So something that has been developed by ISRO is also useful for DRDO. Correct. So that's why in this context, all these developments they become very, very crucial. So what does a scramjet do? So here we of sorry instead of carrying a lot of oxidizers, we can use oxygen in the atmosphere. What does it do? It then reduces the weight of the vehicle, saves fuel, and increases the carrying capacity, of the fuel. So that's why we see that in all these cases, scramjet becomes very crucial technology. And we see that there are a lot of tests that have happened in the recent past, and it means that we are almost ready, and we perhaps might see very soon that something might be announced by ISRO over the next couple of years around scramjet, and not only around scramjet but also around reusable launch vehicle. Again, a technology which has been tested already by ISRO. Even scramjet has been tested. The first successful test of scramjet was done back in 2016, and ever since then we see that even in 2023 another test was done. So testing has been successful fairly, and we are moving now in that direction. Similarly, reusable launch vehicle, another technology that has been tested by ISRO back in 2015 itself. And in case of reusable launch vehicle, what we basically want is that at least a part of the launch vehicle should be reusable, that we should be able to instead of having expendable launch vehicles, meaning that the ones that we can use only once, we can use reusable launch vehicles which can be used multiple number of times. So then in that case, when it comes to reusable launch vehicle, we see that this is what the plan is, that once the launch has been done, the reusable launch vehicle will fall back and it will be collected, and then it will be used again. So this is what we want with the reusable launch vehicle. And again, we see that last year a couple of tests have been done again with reusable launch vehicle. And then lastly, we have NGLV. NGLV standing for next generation launch vehicle. Now, this is where we are looking at replacing our currently operational launch vehicles like PSLVs or even GSLVs for that matter. Now, what we want is that first it should have a higher capacity. The capacity that we are looking towards is up to 10,000 kg. So that's why it is cost effective, three stage, reusable, heavy lift vehicle with payload capacity of 10 tons to GTO. Until now, the maximum capacity that we have is with GSLV Mark III, that has a capacity of up to 4000 kg to GTO. But even 4000 kg is not enough, because if you look at the last couple of launches that we've done, you'll find that these are satellites which weigh 5000, 6000, even 6500 kg. So again, we do not have the capacity, and many of the communication satellites, they will be bulky, they will be more than 5000, 6000 kgs. So that's why this is what we want to develop, a capacity of 10000 kg to geosynchronous transfer orbit. It will have a semi cryogenic propulsion. Now when it comes to semi cryogenic, it means that this is where we are mixing the cryogenic with kerosene. Sorry, we are going to mix kerosene with the cryogenic fuel. So that is why it is being called as semi cryogenic. So again, we also want that we should be able to make it reusable. So until now there is no official confirmation of dates, etc., that this is when we are targeting, this is exactly what we are targeting. But in some of the official events that ISRO has been to, or ISRO officials have been to, this is where they have spoken of that this is what we are working towards, that this is what ISRO is planning next. So that's why NGLV from that perspective becomes crucial, because this is going to be the next generation of our launch vehicles. Now, coming to the fuel that we are using, we discussed about the various fuels. So, for example, we have HTPB, or hydroxyl terminated polybutadiene. This is something that is being used in the first and the third stages of PSLVs, in the first stage of GSLVs, and all three stages of SSLV. Similarly, we have UDMH, unsymmetrical dimethyl hydrazine, and this is something that we are using in the second stage of both PS PSLVs as well as GSLVs. Then we have MMH, or monomethyl hydrazine, something that we are using in the fourth stage of PSLVs, and the velocity trimming module in SSLV. So these are some of the fuels. Plus there is liquid oxygen and liquid hydrogen, and we discussed that liquid form of oxygen is used as an oxidizer in the cryogenic engines. And for liquefying oxygen, we need a temperature of around minus 150 degrees Celsius. Minus 150 degrees Celsius. Similarly, LH stands for liquid form of hydrogen, and this is where you have the fuel in the cryogenic engine, and we need a temperature of around minus 250 degrees Celsius to get this temperature, so to get this fuel. And that's why we know that these two are being used in the third stage of GSLV, correct? So liquid hydrogen and liquid oxygen. And then we have MON, standing for mixed oxides of nitrogen, which basically have nitric oxide, dinitrogen tetroxide, nitrogen dioxide. So a mixture of nitrogen oxides which are used as oxidizers. They are used as an oxidizing agent. So they are used as oxidizers which are mixed with, these are to be mixed with the solid and the liquid fuel. All right, solid and liquid fuel, where they are going to be mixed. So these are the different types of fuels. Now, before we go on to our next topic, that is Indian Space Research Organization, if you have any questions, any doubts, first let's clear that, and then let's move forward. So last 1 hour, whatever we have discussed, if you have any questions, please let me know. NSIL full form. NSIL stands for New Space India Limited. We'll just discuss about that in some time. Please repeat VTM. VTM stands for Velocity Trimming Module. So basically what happens is that once we are near the required orbit, so suppose that, let's say this is the Earth and this is the required orbit. Suppose that this is the required orbit. Now, as we approach, let's say as the rocket has approached this orbit, this is where VTM will be used, velocity trimming module, so that we can align the velocity of this particular satellite with the required velocity. And that is where control becomes very crucial. Controlling how much fuel should flow, what should be the optimum speed, etc. That control becomes useful, and that control is what we provide with the help of this module. What are the precautions while launching a satellite? There are a lot of precautions that we take. Uh, each and every calculation needs to be right. Each and every aspect of atmospheric conditions need to be right. When we would launch, how we would launch, what are the parameters, where are we launching, what fuels are being used, all, each and everything. I mean, it's a daunting task for me to even name what all precautions are to be kept. There are a lot of it. Please show the fuel slide. This is the fuel slide. What is Mac? Mac basically is, so when we say Mac is something with related to sound. So when we say Mach 1 is basically speed of sound. Writing speed of sound. Mach 1, speed of sound. Similarly, anything that is greater than Mach 1 is called as supersonic, because it has a speed more than sound, and anything less than Mach 1 is called as subsonic. So this is what we mean by Mach. SSLV used for, SSLV, as I told you, used for small satellites. Any small satellite, nano satellites, micro satellites, all these can be launched with the help of SSLVs. Vikas engine, in short. Vikas engine, just remember this, that Vikas engine is an engine that we use wherever we have liquid fuel. So any liquid fuel that we are using in our rockets, to launch using in liquid fuel, we need the Vikas engine. Reusable means that the same rocket shall come down and be used. Yes, that's correct. In PSLV, why did we launch other countries' satellite as well? We have the capacity, we were paid for it, we generated a lot of revenue out of it. Why India launched US satellites? They could have launched, see, these are private satellites, and these private companies would go wherever the launch cost is low. Now, when it comes to the PSLV launch cost, it is extremely low. One PSLV launch, for example, costs approximately $15 million, which you might think is huge. But normally, when you look at a NASA based rocket, or even Ariane 5 or Ariane 6 that France uses, all these, they cost in the excess of $100 million for one single launch. And PSLV launch cost is just $15 million. So for a private company which has seen a lot, which sees that PSLV has been fairly successful, and perhaps more successful than the Western counterparts, they would want to get their launches done. Scramjet slide, where is it? This is the scramjet slide. Don't get close to the thrusters when launched. that goes without saying. And anyway, that also is something that they do. Sir, you said scramjet will use atmospheric oxygen, but when the rocket crosses atmosphere, how will it work? Good question. See, basically, what happens is that out of, let's say, even if we are wanting to use the scramjet in PSLV, then perhaps we'll be able to use it only in the first stage. In the second, third, fourth stages, we can't use it because as you go above, the thickness of oxygen, the availability of oxygen will be lower. So then you wouldn't be able to launch a satellite from there. I mean, you wouldn't be able to use the atmospheric oxygen there. So that's why it is something which is largely useful for only the first stage and not the subsequent stages. How we will keep all the full forms of satellite launchers in our mind. PSLV is Polar Satellite Launch Vehicle, GSLV is Geosynchronous Satellite Launch Vehicle, SSLV is Small Satellite Launch Vehicle. That's it. What else? There are only three. And this much you will have to know. Thrust versus propulsion means. So thrust basically is a force. Rather, you can say a force that is being applied in a direction which is opposite to the natural direction or a natural force. So, for example, in this context, the natural force is the force of gravitation, correct? So, the force of gravitation is called as, you can say in a manner, this is the natural force here. So when you are acting against this force, that is what we call as thrust largely. All right, so that is what we call as thrust. And propulsion in a manner is pushing forward using any force. Using force when you are trying to push forward, that is called as propulsion. So propulsion can be in a positive or negative direction, meaning that propulsion could be in the direction of gravity, propulsion can be in the opposite direction of gravity, but thrust will be always opposite direction of gravity, or thrust will always be opposing the naturally occurring force. So even in case of buoyancy, we say the same thing, that the buoyant force basically acts against the natural force. So that's why it is a thrust that comes upward. That is the meaning of thrust. So why ISRO launches satellites only from Sriharikota? Do we have any other launch stations? This is something that we are just about to discuss in some time. Please wait. Ramjet, basically just understand this, that Ramjet is nothing but uh, an air breathing, any jet propulsion engine where we are using or where we want to use atmospheric oxygen will be called as Ramjet. Please show RLV. RLV. Yeah. Does India import fuel? We actually fabricate fuel in India. All right. Fuel fabrication happens in India, but the raw is something that we import. Hmm. So let's move on to our next topic. And the next topic is Indian Space Research Organization, or ISRO. Now, in the context of ISRO, first thing to know about ISRO is the vision. And this one statement of ISRO about ISRO is very, very crucial, because everything related to space in India, space technology in India, is looked after by ISRO. And you can see in a manner it has been a success story for India. Correct. It has been a success story for India because the achievements that we have seen with ISRO, they're unparalleled, they're unmatched. None of the other science-based organizations have been able to achieve as much as ISRO has been able to achieve, and that's why it becomes a model for every other organization to understand how to go about things. So that's why it has been very crucial. And in this context, when you look at the vision statement of ISRO, that makes a lot of sense. Harness space technology for national development while pursuing space science research and planetary exploration. Meaning what? That our primary goal is national development. Our primary purpose is national development while pursuing space science research and planetary exploration. And this is exactly what we have seen. That there have been more than 100 launches that have been done, which have been related to one or the other aspect of something that will help India, which will help the Indian society. And there have been only a few to name, uh, such missions which are in the pursuance of space research or planetary exploration, like the Chandrayaan 1, 2, and 3, Mangalyaan mission, Astrosat mission, Aditya L1 mission. Only six, and the seventh upcoming Gaganyaan mission. That's it. But when you compare that with all the ones that have been uh, launched for something related to India's requirement and India's progress, you'll see that the number goes beyond 100. So that is something that makes it very, very clear that this is what the vision is. And this is one statement that I want all of you to also remember about ISRO. Because this statement, if it can be used in any question, let's say there is a mains question about Indian Space Organization, or maybe about Indian science or development of science and technology in India. This is where these kind of statements can have a very heavy value. So that's why these kind of statements can be actually used there. The mission statements, I wouldn't say are very important, but still, if you see, this is basically about everything that ISRO does: design and development of launch vehicles, design and development of satellites, the INSAT program, the Indian remote sensing satellite program, then applications for societal development, then research and development in space science and planetary exploration. So basically, everything that ISRO does, mission statement is, you can say, a list down of all that. Now, very importantly, we need to also understand some of the key organizational aspects of ISRO, the basic units that we have as a part of ISRO. Now, you do not need to know about everything that you see in this chart. You do not really need to know all that, but there are just a few things that you should know. For example, this entire line, this is an important line. All these organizations are important, plus these two units are important, plus this is important. So these many is what you need to know, and just in one line each, maybe just in one line each, but you should know it. First is VSSC, that is Vikram Sarabhai Space Center. Now, all the full forms are given here. So first is Vikram Sarabhai Space Center. What does Vikram Sarabhai Space Center do? Vikram Sarabhai Space Center is where the launch vehicles are developed, or anything related to launch vehicles. So everything related to launch vehicles will be designed and developed at Vikram Sarabhai Space Center. Then there is LPSC, that is Liquid Propulsion Systems Center. Liquid Propulsion System Center is where fuel fabrication happens. Fuel fabrication takes place at Liquid Propulsion Systems Center. And then we have SDSC, that is Satish Dhawan Space Center. And this Satish Dhawan Space Center is the launch base of India. So this is the launch base infrastructure that India has. So all the launches are done from here. And there are two launch pads that we have here, and these two launch pads do all the launches for ISRO. Then there is URSC, that is UR Rao Satellite Center. Now, when it comes to UR Rao Satellite Center, this is where the satellites are designed. This is where the satellites are designed. This is what it is. And then we have, it was also called as ISAC before, ISRO Satellite Center it was called as. And at many a places, if let's say those notes etc are not revised, they are not updated, then you might still see that it's written as ISAC. So ISAC is ISRO Satellite Center, which now has been renamed as UR Rao Satellite Center. Then we have SAC, standing for Space Applications Center. Now, this Space Applications Center is where we see that crucial devices or instruments or even sensors, they are all developed at Space Applications Center. So that's why it is also very, very crucial. So smaller sensors or devices, instruments, etc., that are going to go on board on a satellite, they all will be developed at Space Applications Center. And then we have NRSC. NRSC stands for National Remote Sensing Center. National Remote Sensing Center, and this basically is about you can say the data processing of all the data that we receive from the remote sensing satellites. All right, so this is basically about the processing of remote sensing data, processing of the remote sensing data. So that is basically what NRSC or National Remote Sensing Center is. Then, apart from that, we have HSFC. Now, all these units that we have discussed until now, they have been here for, you can say, a couple of decades. But HSFC is new. It was added to this list in 2019. And this is Human Space Flight Center. Human Space Flight Center. So, this is basically something that looks after the operations and management of human space flights. Human space flights, including the Gaganyaan mission. So, especially for Gaganyaan mission, keeping in mind the Gaganyaan mission, this particular HSFC was constituted. Now, apart from these, you also see that we have Antrix and NSIL. Now, Antrix and NSIL, they are the commercial arms of ISRO. They are said to be the commercial arms of ISRO. Now, why do we call them as commercial arms of ISRO? They are the ones that look after all the things related to the marketing, the commercial aspects, the revenue generation, the service providing. All these things will be taken care of by these two, that is Antrix and NSIL. Now, here also, Antrix has been here for a very long time. It has been a fully owned Government of India company, and has also been, I think, conferred with Mini Ratna almost 20 years back. But then NSIL is new. NSIL also was added to this list back in 2019. Before this, it was only Antrix. Now the question is, why NSIL? What was the requirement for NSIL if Antrix was already there? And this was also a question that was raised when NSIL was established. That why did we even need NSIL? What was the requirement of NSIL if Antrix already existed? So what the government said, the official response of the government was that when it comes to these two, Antrix is going to be the official response was that when it comes to Antrix is going to be supply based. Antrix is going to be supply based, and NSIL will be demand based. So Antrix will be supply based and NSIL will be demand based. Now, what exactly do we mean by supply based and demand based? Supply based in this context means that Antrix will take care of everything that ISRO already has. So let's say we have a sensor and somebody wants to buy that sensor from us. So then Antrix will look after that. All right. So Antrix will do all these dealings for everything that is already existing with ISRO. It's just like, let's say, a general store. That you go to a general store, you can only buy something that is already available there. Correct? You cannot buy something which is not available. You cannot ask them to manufacture something and bring it for you. You can't. Correct? So that is what we mean by supply based. That's something that is already present. If somebody wants that, we'll provide it. All right. That is what supply based is. And demand based is when somebody wants to place a new request. So for example, let's say somebody says that, can you launch a satellite for us? We'll say that yes, we can launch a satellite for us, and then we'll start working on it. So that is called as demand based. So demand based basically means any new request, and supply based is supply of something already existing. Supply of something already existing is supply based. So this is basically how we see that there is a difference between the roles of NSIL versus Antrix. This was the official, you can say, response of the government. There is said to be an unofficial reason as well, and the unofficial reason could be that Antrix is facing a lot of problems. There are a couple of cases running on Antrix. There are some service delivery problems that Antrix was facing. So it is fighting its own battles. So maybe the government thought that let them fight their battles. Meanwhile, let's have another unit and let it take care of everything financial for us. But this is not what you can write in your answer. You cannot write that unofficially this was the reason or this could have been the reason. But what officially has been given as the reason is what you should know. No. Now comes in space. Now in space is something which is called as Indian National Space Promotion and Authorization Center. Indian National Space Authorization and sorry, pro, promotion and authorization center. Now in space basically has been devised in a manner that it can help in the development of the private sector in India, or it can provide help to the private players in India, so that it can lead to the growth of these private companies, especially in India. Now, when it comes to this, basically that's why it becomes, you can say, in a manner, a kind of a nodal agency that will also help in ensuring uh, that it can help in the participation or facilitate the participation of the private entities. So non-governmental but private entities is what could be helped with the help of InSpace. So that's why it will help in promoting. So it will promote, enable, authorize, and supervise the various space activities, the various space activities of what they have mentioned as non-governmental, non-governmental private entities. Non-governmental private entities. So this basically is the role of InSpace in the context of India. So that's why there are all these things that you should remember. So that's why from the prelims perspective, maybe one line each about them, that what is their role, what do they do, that much should be important, because all these, they have played a very crucial role in the context of development of Indian space technology. So that is why this is the organizational structure of ISRO. So if you see, these are all the different centers that we have in ISRO, and they are located at different places. You don't really need to know where exactly they are, but as you see, most of them are here in Bengaluru. The headquarters of ISRO is in Bengaluru. Apart from that, ISRO Satellite Center or URO Satellite Center is here. LPSC is here. So all these things are present in. Antrix also has its uh, office in Bengaluru itself. So that's why it becomes very crucial. Then apart from that, Thiruvananthapuram is where you have the Vikram Sarabhai Space Center. And then The launches are done from Sriharikota. So space Satish Dhawan Space Center is located at Sriharikota. Then Hyderabad is where you have the National Remote Sensing Center, and Space Application Center is in Ahmedabad. So that's why these are some of the important areas, you can say, where you have the important units of ISRO placed. Even for example, HDF, sorry, not HDFC, HSFC. HSFC is also here in Bengaluru. Then NSIL also is in Bengaluru. So that's why Bengaluru becomes crucial. And then there is a distribution of other units here and there. Now, in the context of our launches, what we basically see is that apart from the launch station that we have here in Sriharikota, this is where we have Sriharikota. We have another one that we are planning, another spaceport being planned at Kulasekrapatnam in Tamil Nadu. So as you can see this news, ISRO to begin work on second launch pad soon. Now this is where we see that in Kulasekrapatnam we are planning that we should have another spaceport. Now the question is why? First question is, why do we launch all our satellites only from Sriharikota? Why did we even choose Sriharikota? And then there's the second question that in the presence of Sriharikota, why have we thinking of having another spaceport in Kulasekrapatnam in Tamil Nadu? So try to understand these two things. Now, when it comes to this question, there are two things that you will always see with regards to any launch that is done by any country. First thing that you will see is that launches are always done eastward. Launches are always done eastward. And the second thing that you will notice is that launches are preferred to be done near the equator. Now the question is why? First, why are the launches always done eastward? Second, why do we prefer to do the launches from near the equator? Now, in this particular scenario, as I see many of you already have written the reason, that's great. So, when it comes to when you look at the Earth, so what you will see is that the rotational speed of the Earth is the highest at the equator and lowest at the poles. And in this context, when it comes to the Coriolis force, that's something that you might have discussed about in geography. So Coriolis force is something that is the max, that is something which becomes zero on the equator, so makes it easier for the launches to happen. So now in this particular scenario, what happens is that because of that, doing the launches from near the equator becomes more feasible. It will use lesser fuel as compared to the amount of fuel that you will be using if you are doing the launches from a temperate region or from the polar areas. So it's not that you can't do it from there, you can do it from there, but at a higher cost, but with a lot more fuel. So that is where launching it from near the equator becomes more feasible. So why are we preferring from near the equator? The reason is that this is where at the equator, Earth's rotation is maximum. Coriolis force is zero, making the launches more efficient. This is one reason. The second thing is when it comes to why are we launching it eastward? The main reason why we are launching eastward is that the earth rotates from west to east, correct? So if it is rotating from west to east and the launches are being done eastward, it would mean that it would be able to gain a lot of speed. It will be able to gain a lot of velocity because of the movement of the earth. So then again, the fuel requirements will be lesser as compared to if we were doing a westward launch. So that's why eastward launch. So eastward launch because the earth rotates from west to east, hence the launcher gains maximum relative velocity when launched eastward. So this is what we see in this context. So that is why Sriharikota, because Sriharikota is in Andhra Pradesh and it is basically, you can say, near the equator and also on the eastern coast. If we had chosen a western coast, we have to fly over the Indian subcontinent, correct? That can be unsafe. If any accident happens, any mishap happens, that could be dangerous. So that's why we cannot use the western coast. We have to use the eastern coast. And that's why you'll see that most of the launches that are done worldwide, they are done from the eastern coast, all right, either from islands or from eastern coast. So that's why Sriharikota was chosen. Now why Kulasekrapatnam? One more thing that you have to understand is that we want to launch towards the equator. So now, while launching towards the equator, we cannot directly go south. Instead, we'll have to take a longer path. Why longer path? Because we want to also avoid Sri Lanka. Only Indian lives don't matter. Sri Lankan lives also matter. So that's why we cannot go southward. Now, when it comes to Kulasekrapatnam, it makes it easier for it to go towards the equator. It will not have to take a longer path to avoid Sri Lanka. It can very easily avoid Sri Lanka in its natural path. So that is the reason why we thought that Kulasekrapatnam can be a very, very important area, a very crucial area, which can also have a spaceport. And that's why this second spaceport has been suggested for Kulasekrapatnam. Now, coming to the last topic of discussion in this particular chapter, and this is about space debris. Now, space debris basically is nothing but, you can say, the machinery or the instruments or small particles here and there that have been left in space by humans. So that will be called as space debris. Now, so that's why it can refer to big objects such as dead satellites that have failed or have been left in orbit at the end of their mission. Or it can also refer to smaller things like bits of debris or paint flecks, etc., that have fallen off a rocket. So anything big or small that for one or the other reason, something that has been left by humans in space will be called as space debris. And if you look at the data suggests that only 7% of space debris are the operational launches, or seven objects are space objects are operational satellites. 65% 65% are non-functional objects, and 28% are just smaller fragments. And overall, that's why when we look at some of the data, there are more than 4,000 active satellites in the Earth's orbit, almost 3,000 dead satellites in the orbit, 34,000 pieces of space junk which are larger than 10 centimeters, 128 million pieces of space junk that are larger than 1 millimeter. So that's why we have seen that this number has been increasing, and increasingly it is going to create a problem for the future missions. And in this context, we see that there is this concept which is called as Kessler syndrome. Now, this Kessler syndrome, this is an idea that was proposed by a NASA scientist, Donald Kessler. And what he said is that if there was too much space junk in the orbit, it could result in a chain reaction where more and more objects could collide and create new space junk in the process, to the point where the Earth's orbit became unusable. Unusable. So we are saying that it might so happen that maybe two satellites collide, or a satellite collides with a space junk, and it creates a lot more of space junk. So much so that all the other satellites also which are in the same orbit, they also keep coming and they also collide with the space junk, and this leads to a chain reaction in a manner that the entire orbit becomes unusable. And today, it was an idea back in 1978. Today it is on the brink of becoming a reality, especially for the low earth orbit. For the low earth orbit it is becoming a reality, because for the high earth orbit it's still not a problem, because high earth orbit is a much larger area and with much lesser number of satellites. But in case of low earth orbit, we see that there are so many private companies, so many private players, so many government agencies. They keep on launching their satellites, small satellites, nano satellites, normal earth observation satellites. So when it comes to the low earth orbit, it is much more crowded. It is much more crowded today, and that's why today we are looking towards how to actually tackle this problem. What exactly can we do to tackle this problem? And we are looking towards various ways in which we can clean up the mess. We can clean up the space debris that we have created, especially in the low earth orbit. So in that context, what we see is, for example, if you take example of ISRO, we have we now have a system which is called as the Netra system. So this Netra system basically is for identifying the Indian space debris. To identify Indian space debris so that we can take care of them. Identify the Indian space debris. Then after that, what we see is that there are some of the other efforts. For example, we see that whether it is NASA or whether it is European Space Agency or even the Japanese Space Agency or JAXA, we see that they all also have been working on various different techniques, like creating a missiles that can shift the larger pieces of space junk away. Japan is working on a concept which is like, you can say, a fishing net that can collect all the space debris. So there are all these efforts that are being made today by the different governments, by different space agencies, to take care of the kind of space debris situation that we have created, especially in the low Earth orbit. So when you look at the data with regard to the number of space debris, obviously Russia, United States, and China, they have the largest number of space debris that they have created. And compared to that, other countries, they have fairly less number of space debris today in the low Earth orbit, especially. Now, let's take a break here. We'll look at the mains questions after we come back from the break. Meanwhile, if you have any questions, please post all your questions. When we come back from the break, I'll take all your questions first, and then we'll move on to the mains questions, and then we'll start our next topic, or the next chapter rather, which is biotechnology. But before going there, let's take a break. It's 6:40, so let's be back by 6:50 and continue with our discussion. Welcome back, everyone. So, first, let's start with our mains related questions that have come from this particular chapter of space technology, and then we'll move on to our next chapter. So, if you look at the questions that they have asked, and first thing, let me tell you that you'll find that almost every year, one question does come from space technology in your mains examination. So 2023 they have asked, 2022 they have asked. Only two COVID-19 years, that is 2020 and 21, is where they did not ask a question on space technology. But before that, again, you'll see that 2019, 18, 17, 16, 15, 14, you'll find that every year, one question does come from space technology. So that's why it's a very, very important topic from mains also. Now, if you look at the first question that we have here, 2022, launched on 25th December 2021, James Webb Space Telescope has been much in the news since then. What are its unique features which make it superior to its predecessor space telescopes? What are the key goals of the mission? And what are the potential benefits? What potential benefits does it hold for the human race? So in this context, what we see is that there are three questions rather they have asked you in this question. So first, you will have to start with a basic introduction to what is James Webb Space Telescope. Then after that, you will start writing about the unique features and why is it superior to its predecessor telescopes. So in case of unique features, first things first, that it is an infrared telescope, very, very important. It has been placed at L2, that is also very, very important. And in terms of its predecessor, now predecessors wise, you can say that there are two telescopes that we could probably call as predecessors. One is the Hubble Space Telescope, right? So Hubble Space Telescope has been very, very crucial in this context because it has been the space telescope that has given immense amount of information in the past 25, 30 odd years. So one is Hubble Space Telescope, and then there is something called as the Spitzer Telescope. So Spitzer Telescope also, because it was an infrared telescope, that's why we are calling it as a predecessor. So these two can be called as predecessors. And uh, when we look at the properties, when we look at the kind of instruments that have been used, the sensitivity of the telescope itself, they're much better as compared to all these. So that's why these all things can be written. Plus, the key goals of the mission is to have a basic understanding of the universe, especially the early universe, and gain the unknown knowledge about the universe, something that has remained unknown for us. So that also is where infrared will be very, very crucial. And then lastly, potential benefits, that we would have a better understanding of the universe. At the same time, it will also help us in development of further technologies. The the basic know-how from this mission will help in the future also, and it will be very, very important for the upcoming missions that perhaps is being planned by NASA. So there are all these things that can be said in the context of the James Webb Space Telescope. Then the next question, what is India's plan to have its own space station, and how will it benefit our space program? Now, this in a manner you can say that it was also driven by news, this question, because in 2018, India had clarified, because there were some news about whether India is going to join the International Space Station. So this is where India had clarified that no, we are not going to join the International Space Station, but rather we are looking at our own space station. We are trying to build our own space station, and after we are done with the Gaganyaan mission, the next big project that India is going to start is going to be our own space station. So this is where we see that this becomes a very important news, and this news is where this question is based upon. So, what is India's plan? So, this is India's plan that after the Gaganyaan mission, we want to start working on our own space station. And back then, it was said that the target year for us would be 2030. That by 2030, we would have our own space station. But back then, the Gaganyaan mission also was supposed to be launched by 2021 and 22. But now it already has been delayed by almost 3 years. So probably these kind of programs also will be delayed by 3 years or so. How will it benefit our space program? Couple of things. One, that it becomes a support system. International Space Station, for example, it acts as a support system for the satellites that we have in the low Earth orbit. Similarly, our own space station will also become a support system for our own satellites in the low Earth orbit. Then, at the same time, it will also help us in gaining some knowledge about the space environment, about the microgravity situation, about how the human body and the other organisms, they respond to this kind of a scenario in the space. So we will gain a better knowledge about space environment, and based on that we can uh, look towards the future. So there are all these things. Plus, if you look at the next question, why is Indian regional navigation satellite system needed? How does it help in navigation? So something that we have completely discussed in our discussions, that what is IRNSS, what does it do, why is it important, why did we think of building it? So we discussed all these points. How does it help in navigation? So you can talk about triangulation, and how with the help of triangulation and a set of 7 satellites it will be able to provide all this information. Then another question, if you see, India has achieved remarkable successes in unmanned space mission, including Chandrayaan and Mars orbital missions, but has not ventured into manned space missions, both in terms of technology and logistics. Explain critically. So the thing is that we are talking about that, okay, we have had so many missions, but why not any human space flight yet? So now we know that Gaganyaan mission is going to be our first human space flight. So that's the context in which this has been asked, and this was around the time when the discussions around Gaganyaan mission had started, before official confirmation was given by our Prime Minister on 15th of August. So that's why in that context we see that this question was asked. So there are two problems. One, technologically, there are a lot of things that we need to do to ensure, first and foremost, the safety of the crew members. Anyone who's going into space, we have to ensure that they are as safe as possible. So safety concern. So with that, all the other things, for example, the space suit and everything else, all these things will have to be ensured. Plus, logistically, it's a lot. For example, the cost itself, the total budget of the Gaganyaan mission is beyond 10,000 crores. So that's a big mission. It's a very cost intensive mission. So logistically also there are a lot of requirements that it needs to fulfill. Then only this mission can be made successful. So that's why there are a lot of these things that we'll have to take care of before we can launch something like this. Then 2016, this question was asked, discuss India's achievements in the field of space science and technology, how the application of this technology has helped India in its socio-economic development. Now, there are a lot of points to write. And probably, even if, let's say, this was not a 200-word question and it was a 400-word question, yet you will be able to very easily write an answer to it, because there are so many points to discuss. You can either, for example, for the first part of our discussion, discuss India's achievements in the field of space science and technology. You can either go chronologically, that okay, in 1950s we achieved this, 60s we achieved this, 70s we achieved this. Either you can do that, or you can go according to various sectors, that this is what we have achieved in agriculture, this is what we have achieved in disaster management, in communication, in navigation, in defense. So there are n number of things that you can discuss. So either way is fine. You can go chronologically, or you can go sector wise. And then India's socio-economic development. So socio-economic development was, think of the socio-economic parameters. Agriculture is important. Safety in disaster management is important. Employment generation because of the space sector is important. So there are different points that you can write. There are so many points that can be written in this answer, but the word limit is only 200 words, so you have to be very cautious. Then 2015, this question was asked, what do you understand by standard positioning system and precision positioning system in the GPS era? We discussed about this, that we have standard positioning service and the restricted service in IRNSS. Same is what you have to write here. Discuss the advantages India perceives from its ambitious IRNSS program employing just 7 satellites. So again, a very simple question. You can very easily write this answer, and something that we have discussed in our classes. So if you see that most of these questions that they have asked, these are pretty simple, straightforward questions. Also, many of these questions have been taken from either static areas or the news articles which were immensely discussed over the course of time. So that's why these are not taken from areas which are hidden areas as such. Okay, so any question, if you have anything that you want to ask from all our discussions in, let's say, last 1 hour or so. So if you have any questions, please let me know before we move on to our next chapter, that is biotechnology. In space again. So the basic agenda of in space is to help the private entities, meaning that if there is a private company which is working in the space sector in India, then in space intends to help that company technologically, understanding of space science, procurement of material, whatever it is. So that is why we are saying that it will help the non-governmental private entities. That is what the role of InSpace is. PSLV C-58 ExpoSat mission for zero orbital debris mission. Yes, that's correct. This is a new experimental launch that we have done recently, and let's see where exactly the data takes us and what are we able to achieve with it. Why eastern coast only for launch? Why not west? We just discussed this, that we always launch eastward. Why do we launch eastward? Because the earth rotates from west to east. So to gain that speed of rotation, we want to launch eastward. And that's why we don't want to launch from west coast, because then we'll be flying over India. If any accident happen, any mishap happens, it can fall over India. So that's why we don't want to take that risk. Repeat, HSFC couldn't understand. HSFC is Human Space Flight Center, and Human Space Flight Center basically means that this is something that has been established so that we can help any human space flight that India wants to take. So currently, for example, the Gaganyaan mission. So the Gaganyaan mission is the first human space flight center that we are launching. So then in that case, it is going to help Gaganyaan mission, and in the future other space missions that we take where human crew is supposed to go, human space flight center will help it. Name of the people chosen for Gaganyaan important? Not really important. There are four people who have been chosen, so their names I don't think should be very important. Yeah, so there is, I think, Angad Pratap, there is uh, Ajit, there is Pratap, and there's Shubham, I think. So there are these four people, but sorry, not Shubham, Shubhanshu. So I think these are the four people, but I mean, I don't think that names should be important. All these space agencies working together or individual for space debris? Why not together? Many of them are actually working together. For example, especially European Space Agency and NASA, they very often in these kind of projects they do work together. So, and many of the technologies, they are not technologies that have been independently developed, but rather technologies where they have taken some help from some other organization. For example, ISRO very closely has been working with NASA. European Space Agency has been very closely working with NASA. So we see that many of these agencies, they do work together. Chinese Space Agency has worked with, or has been working with Russia for a lot of these projects. Even Japan has been working with NASA in many of the projects. India has been working with Japan in some of the projects. So it's not that they all have been working independently. They are working, I mean, obviously, because we have our own scientists, so we work on a lot of technologies, and anyone who develops one also shares with others. So it's not that they don't work together. Does Antrix sell the products of ISRO? Yes, it does. Many of the sensors, even paints, for example, are being sold in the market. But only if, let's say, it is not something which is very strategic in nature. If something which is very static in nature, that wouldn't be sold. Something which is a common knowledge can be sold. Is it important for us to know the current affairs rather than general matters in space science? Actually, both are important. It's very difficult to say that one is important and the other is not. Many times, what happens is that the questions that they ask, they are purely static in nature, but they have asked it because there was some current affairs related to it. It was which was in the news. For example, let's say they ask a question on Lagrange points, so they will ask you a pure science Lagrange point question that we discussed in our lectures. But why did they ask that question? Because Lagrange points have been in the news. Sometimes it can be a direct current affairs, news based direct current affairs, that they have directly extracted the information from the news and they have asked it. But sometimes they would ask a static question because it was in the news. So actually, both the things happen. So that's why we cannot say for sure that this is what they will ask and this is why they would ask something. What is space debris? As I told you, that anything that has been left in the space by humans can be called as space debris. Any book for science and technology for basics, please. Apart from NCRTs, please don't read anything else, because otherwise it wastes a lot of time for very little output. So that's why listen to the stories in the classroom and add on current affairs to it. Don't do anything extra apart from that. But please read some of the NCRTs that I suggested, especially class 6 to class 8th NCRTs. That should be enough. Why in PSLV polar is used? Because largely it is used for launching polar satellites in the low Earth orbit. Low Earth orbit is polar in nature. So that's why largely it is launching the satellites which are in the polar orbit. That's why the name Polar Satellite Launch Vehicle has been given. Please once tell us about a trip again. What trip? I could not get your question. Can you specify? Antrix. Oh, sorry. So Antrix basically is, you just understand this. We say that Antrix is a fully owned government of India company. What does it do? It looks after the commercial matters of ISRO. So anything that, for example, let's say somebody wants to buy something from ISRO, they can approach Antrix and they would be buying that technology or that product or that component through Antrix. That is the role of Antrix. Right. So now let's move on to our next chapter, which is biotechnology. Now, when it comes to biotechnology, first from the perspective of your prelims and mains examination, this again is an important chapter. Especially in your prelims examination, it has been very important, because I don't remember any year when a question in your prelims examination from biotechnology hasn't been asked. Questions in mains examination are fewer. Not every year they ask a question, and also the questions in the mains examination have been fairly easy. They've asked very easy questions in the mains examination compared to what they've asked in prelims. So in prelims, we have seen that current affairs also has played a very important role in biotechnology. But again, in prelims, just remember that in prelims, I would say it's more important than in mains examination. Now, as a chapter, it is not as big a chapter as the first two chapters were. Now, going forward, none of our chapters are going to be as big as the first two chapters have been, where we have taken 6.5 classes only for finishing the first two chapters. The upcoming chapters, they are not going to take so much time. All the chapters, for example, biotechnology, will be able to finish tomorrow. We'll be able to start with nanotechnology as our next chapter, perhaps. So all these chapters now which are coming up, they are smaller chapters. Now, biotechnology. First, to understand what do we even mean by biotechnology. Just give me 2 minutes. Sorry for this. Am I audible and visible? Good. All right. Tomorrow class? No, tomorrow I don't think we have a class. We'll have our next class on Monday. So when I say tomorrow, I mean the next class. It's just out of habit that many a times I would say tomorrow. I don't think you have classes on Saturdays. Do you have classes on Saturdays? No, right? Hmm. So yeah, coming back to our topic, biotechnology. Now, biotechnology, just first try to understand what do we even mean by biotechnology? What is biotechnology? Now, here it is derived from two words. You can break it down into two words, bio and technology. Bio coming from a word that is bios. So, bios is something which is related to the living. All right, something related to the living. So for example, when we say biology, so biology also comes from this word bios, so which is study of the living things, study of the living beings is called as biology. So bios basically means living in a manner. Technology, okay, what is technology? We are discussing this chapter of, or rather the subject of science and technology. Can you tell me what is technology? What according to you is technology? What according to you is technology? Developments, modern development to make human life better. Good. Applying the process, advancements in tools and technologies to harness the efficacy of energy, technique of change, application of science. This is, I would say, the exact thing that it is. What Tirtha you have mentioned and Kartikaraj you have mentioned, it is application of science. So when you say technology, yes, it is correct that it is, it makes human life better. It is about modern developments. It helps in a lot of different things. Uh, Advancements in the prevailing methodology. This is all correct. Innovations and inventions. So all this is correct. But exactly if somebody asks me what is technology, I would say it is application of science. So technology, we would say that it is application science, because what have we would be discussing? Everything that we discuss as technology has been derived from where? From science. For an example, in space technology, how are we launching satellites? For that, there is physics that is working behind the scenes. Why are fuels so efficient? There is chemistry that is working behind the scenes. Everything that we are going to discuss in this chapter, there is biology that is working behind the scenes. So it's application of science. Whenever we say technology, it's application of science. So when we say biotechnology, it is in a manner application of living organisms, the use of living organisms for one kind of application or the other. Any application that makes human lives better, or maybe also makes other animals and plants lives better. So that will be called as biotechnology. So that's why biotechnology, the word has come from two words. One is bios and the other one is technology. And that's why defined as application of living organisms and their biological processes in order to make best use of living organisms for the benefit of the humankind. So that's why in this context, we'll say that when it comes to biotechnology, it makes the lives better By applying science, by applying the science behind the living organisms. That's why it is the use of living organisms. Now, how do we use the living organisms? Now, there are multiple examples in front of us. There are some examples where, for hundreds of years, or probably more than 1,000 years, we have been making the use of biotechnology without realizing that it is biotechnology. Simplest of the example, making curd out of milk. How do you make curd out of milk? You take a bowl, you keep milk in it, you add 1 spoon of curd in it, leave it overnight. Next morning, you will see that milk would have converted into curd. This is what happens, right? Leave it for 6, 7 hours, milk would have converted into curd. As simple as that. This is what we do. What is it? It is biotechnology. Why is it biotechnology? Because there are certain bacteria called as lactobacillus, and these bacteria, they, once they are in the milk, they get, you can say, uh, a medium where they can multiply, and they keep on converting milk into curd. So that is what they do. They are found in the curd, and from the curd, once they go in this medium of milk, they would convert milk into curd. That's why in 6 to 8 hours, you'll see that milk would have converted into curd, right? So this is basically what happens in case of curd. Now, the use of curd is biotechnology, but perhaps we did not know that what we are doing. These are more of hit and trial methods, that by mistake somebody created curd, and then they realized that curd is good, curd is food, curd helps in digestion, and so on. So then they started using curd, then they started making curd and made it a part of their food. Similarly, there are other applications, preservatives, a lot of natural preservatives. They can be called as biotechnology, because that's also the use of the living organisms, plants and animals, etc. Interestingly, also making alcohols, fermentation, the process of fermentation. The process of fermentation is also perhaps something that we have been using for more than 1,000 years. If you go back into history and you start looking at the process of fermentation, you'll find that fermentation actually came before making curd. So making alcohol is what we learned before we learned how to make curd. So you can say, in a manner, the human race had its priorities straight. That first we started to understand how to make alcohol, and then after that, later we realized that, oh, curd can also be made. So all these processes could have been hit and trials. That it is not that we used some technology or we used that science because we knew what we are doing, but perhaps we stumbled upon it. So that, in that sense, you can say that when it comes to biotechnology, biotechnology is being used for a long time. But in the context of what we are discussing is modern biotechnology. And when it comes to modern biotechnology, it is the use of genes, it is the use of the DNA, and how exactly these genetic material, they can be important for the use in biotechnology. So that's why, before we go on to understand that there are various different applications where we are making the use of biotechnology today, let's try understand the basics. The basics of some of the words that we will be constantly using in this chapter: genes, chromosomes, DNA. Now, to understand this, let's start with an organism. When we talk about any organism, a plant, an animal, humans, all these organisms, you might know that these organisms, when they come together, they make populations, right? The various populations of different organisms, when they come together, they make communities, correct? They make communities, and these communities, when they come together, they make a ecosystem, they make an ecosystem. And these ecosystems, then when they come together, you can say that they entirely make up the biosphere, correct? Where all the living and the non-living parts, they interact together. So in this manner, you can say, this is in a manner the ecological hierarchy that we see. So organism together, let's say any bunch of similar organisms, similar species will make the population of that species. Different populations of the species together, they make a community. Different communities coming together will make ecosystems. Different ecosystems together will make up the biome or the biosphere. Now when it comes to, when we look inside the organisms, these organisms, they are made of organ systems, correct? So for example, you can say that we have the digestive system, respiratory system, and all that. All these organ systems are made of different organs, correct? Like heart is an organ, brain is an organ, and so on. All these organs, these are made of tissues. Tissues are bunch of cells that come together for a specified function. So there are tissues, and these tissues are made of cells, correct? These tissues are made of cells. And how do we define a cell? We say that a cell is a fundamental unit of life, correct? It's a fundamental unit of life. You can say it is the basic structural and functional unit of life, correct? It is the smallest structural and functional unit of life. This is what a cell is. Why are we saying that it is the smallest structural and functional unit of life? Because a cell on its own can exist independently, right? For example, we have so many unicellular organisms, meaning that this is an organism which is made of one single cell. And one single cell in itself, it's a functional unit. It is doing everything on its own. It is surviving on its own. That's why we say that the cells are the smallest structural and functional unit of life. Now inside the cell, when we go one step beneath, we see that inside the cell there are various different types of organelles. You might have heard of the mitochondria, for example, that there is mitochondria. There uh, there is cytoplasm, there is a nucleus. Now here, in this context, nucleus becomes very, very important. Nucleus, inside the cell we have the nucleus, and we say that nucleus is like the brain of the cell. We call it as the brain of the cell. Why do we call it as the brain of the cell? Because it controls and coordinates all the activities inside the cell. It just like how our brain works. Our brain controls and coordinates every activity that we perform. So similarly, the nucleus inside the cell, it also controls various activities inside the cell. Not only that, nucleus contains something called as chromosomes. Nucleus contains chromosomes, and these chromosomes, they contain all the specific properties that an individual has. All the specific properties of an individual, they are there inside these chromosomes. And these chromosomes, you can say, they are made of bunch of genes, and these genes are made of various segments of DNA. So that's why you can say that there are various different uh, levels of organization. There are various levels of organization. For example, this you can say is the ecological, this is the ecological level of organization. Similarly, you have this at an organism level. And then the third one, you can say that this is the cellular level. Cellular level of organization. Cellular level of organization. So in this manner, we see that there are different levels of organization. Now in this context, when we look at inside the cell, or rather inside the nucleus, nucleus becomes very, very crucial, because nucleus contains all the specific properties of any individual, whether it's a human, whether it's a plant, whether it's an animal. all this information is inside the nucleus. So that's when nucleus becomes very crucial in this context. And here we have these three levels of organization inside the nucleus, where you have chromosomes, genes, and DNA. So let's try to understand, what do we mean by chromosomes, what do we mean by genes, and what do we mean by DNA. Now, inside the nucleus, we know that we have chromosomes. Now, these chromosomes, as you see in the picture, they look like this. So they are long, coiled up, thread-like structure which are made of DNA and proteins. And they carry the genetic information in the form of genes, which is found in the nucleus. And in humans, for example, there are 23 pairs of chromosomes. 23 pairs, meaning that a total of 46 chromosomes is what we have. 46 chromosomes in total. Now, these 46 chromosomes that we have, they contain everything. Every individual characteristic is just listed in these 46 chromosomes, or 23 pairs of chromosomes, out of which there are 22 pairs which are called as autosomes, which are similar in males and females. And there is the 23rd pair of chromosome, which is called as the sex chromosome, which determines whether somebody will be a male or will be a female. So in humans, out of the 23 pairs, 22 pairs are similar. The 23rd pair is what differentiates between a male and a female. So that's why chromosomes. So chromosomes contain all this. So chromosomes, as you can see here, chromosomes contain all this. And when we look inside the chromosome, so as you can see that inside the cell we have the nucleus, and when we look inside the cell, inside the nucleus, we find the chromosomes. And here is where we have genes, which are made of segments of DNA. We have genes which are made of segments of DNA. So basically, you can say that DNA are small, very small proteins, and bunch of these proteins together will make up a particular gene. And every particular gene is responsible for a particular function. And that's why these genes, when they are passed on from generation to generation, they are responsible for the various characteristics. For example, the similarities that one might see between two generations, between a mother and a son, or between a father and a son or a daughter. So that kind of similarity that we see in properties, that comes from these genes. And that's why there will be a gene for every aspect of our properties. For example, color of the eye, color of the hair, color of the skin, all these things are determined by a specific gene. How many hair will be left on the scalp after a point in time, that will also be determined by genes. So that's why there is a gene for each and everything, each and every property. The height of an individual, for example, largely also there is a gene that is responsible for it. So everything is determined by one gene or the other. So that's why these are segments of DNA. These are segments of DNA that contain the instructions for development and function of living organisms. And that's why they become the basic units of heredity, and they are passed on from parents to the offsprings. So that's why we see that these genes also can have different variations or variants, which are also called as alleles, which can result in the variation in the traits. For example, hair color, height, eye color, etc. All these are inherited because of various different differences in the genes. So that's why genes become the property that are, I mean, every single gene is responsible for something. And these genes are made of segments of DNA. As you can see here, that they are made of segments of DNA. So bunch of DNA together, they make up a particular gene, and that gene is responsible for some kind of property. Now, then comes the DNA. So DNA basically is the molecule that contains information about the growth, development, functioning, and reproduction of all the living organisms, and made up of four chemical bases. Base meaning that it is basic in nature, like acid and base. That base is what we are speaking of. So we have adenine, guanine, cytosine, and thiamine. These are the four chemical bases that make up this DNA. Now, these bases, they are arranged in a specific sequence which determines the information that is stored inside their DNA, and they always arrange in a very specific way. So, for example, adenine always combines with thiamine, guanine always combines with cytosine, and they together, they would make up the various different, you can say, characters, and they would come together in various different permutations and combinations, and these combinations will determine what kind of gene is made. So for example, it could be one AT coming with one GC, or it could be one TA coming with one GC, or it could be one TA coming with one CG, or it could be one AT coming with one CG, and so on. And then there combinations. So all these combinations, they would ensure that there are various different types of genes that are being created. So that's why DNA becomes very crucial, because that becomes the basic building block of any gene. So segments of DNA, that's why these segments, they would together make up a DNA, make up a gene. Now, when you can also understand this, let's say if I take an analogy of a book, suppose that you have a book. Now this book is made of different chapters, right? In these chapters, there are various different things written, various sentences written. These sentences, these are made of words, and these words are made of letters, correct? So you can say that in a manner, all these letters that we have, these are like the chemical bases, the AGCT that we are talking about. So these are like the chemical bases, ATGC, etc. Then these letters, they would make up a word, right? So this word that you have, these words are like the DNA. Then the sentences, the logical sentences that are made out of these words, you can say that these are like genes. All right. Then out of this, when you are making a chapter, each and every chapter is like the chromosomes. Each and every chapter, these are like the chromosomes. And you can say that in a manner, there are 23 pairs of chapters. All right, there are 23 pairs of chapters which are chromosomes. And ultimately, this entire book is something that we also call as the genome. You can say that this entire book becomes the genome, which contains every bit of information of an individual. So in this manner, you can try to understand this analogy to understand what exactly is the level of differentiation between all these things. Now, apart from DNA, there is a very similar kind of protein, which is called as RNA. So we also should know about what do we mean by an RNA. So when you look at a DNA, for example, you can say that they have a double helical structure. It's like a twisted ladder, that you take a ladder and you twist that ladder. So kind of the structure that you get then is the DNA structure. All right, that is the double helical structure. And in case of RNA, RNA has a single helical structure. So it is a double stranded molecule, and RNA is a single stranded molecule. That is the basic difference between an RNA molecule structure and the DNA molecule structure. As you can see that this is what the DNA molecule is like, right? This is the DNA molecule, and RNA molecule, as you can see, that it is a single helical structure. All right. So that is the basic difference in their structures. Then, apart from that, there are other differences. So, for example, when it comes to the function that DNA has, so DNA would carry all the genetic information, right? It will carry all the genetic information, and that's why it becomes very, very crucial in storing all the information, it's specific information about individuals. Whereas when it comes to RNA, RNA helps in the transmission of the genetic code required for protein production from the nucleus to the ribosome, meaning that they help in production of proteins. They make the different types of proteins that are required for the growth and development of the cell. All right, they carry the instructions, or they carry the instruction for making these proteins that are required for making, or they which are required for making the proteins that are required for the development and growth of the cell. So that is the basic difference. One carries the genetic information, the other one makes the proteins required for the growth and development of the cell. So that's the basic difference between the function of DNA versus function of RNA. All right. So apart from that, that's why other differences are that the sugar that it has is deoxyribose versus ribose. Then when it comes to DNA, it is found in the nucleus, whereas it is also found in mitochondria. Apart from that, in the plants, it is also found in plastids. In plants, it is also found in plastids. Largely, we know that DNA is found in nucleus, but it's not only the nucleus, but also mitochondria and also plastids where we find the DNA. They also have their DNA. And RNA is found everywhere in cytoplasm, in nucleus, in ribosomes. They all consist of RNA. So not only nucleus, not only the wherever you have the genetic information. One more difference is that we have adenine, guanine, thymine, and cytosine in DNA, whereas in RNA we have guanine, adenine, and cytosine, which are similar, but instead of thiamine, we have uracil. So there is one difference here as well. So that's the basic difference between DNA and RNA in their structure, in their function, in where they are located, in what they have, what they are made of. Everywhere we see that they are different, although molecule wise they are similar in their structure, with small difference in the kind of sugar that they contain. All right, so that is the basic difference between DNA and RNA. So that's why just understand that when it comes to the DNA, genes, chromosomes, they're not same, because very often what happens is that we keep on using these words interchangeably, but there is a specific meaning that DNA is the building block, the basic building block. Genes are the segments of DNA, and chromosomes are the houses of the genes. So that's the basic difference that we have between these three. I hope that this clarifies the basic differences that we have in all these cases. Now coming to our discussion, the discussion of where we what we are going to discuss in this chapter, and this is about the various different applications of biotechnology in various different fields. Now, when we look at the various different fields and how these are different in the context, what we see is that overall, when when it comes to uh, the branches of biotechnology, the branches of biotechnology is where we see that there are differences. And overall, when it comes to the branches of biotechnology, very peculiarly, we have given different colors to different branches of biotechnology. Depending on what they are being used for, we have color coded biotechnology. So one, for example, if you see this, we have green biotechnology. So green biotechnology is when we are using biotechnology for agriculture. Similarly, when we are using biotechnology in the medical field or in healthcare, we have named it as red biotechnology. Then blue biotechnology, anything related to water. Anything related to water related applications, blue biotechnology. White biotechnology for industries. Wherever for any industrial application we are using biotechnology, it is white biotechnology. Then we have gray biotechnology for the environment. For any environmental application, it is gray biotechnology. Then brown biotechnology for arid areas, for wherever we have scarcity of water, limited supply of water, then in that case, it is brown biotechnology. Then violet biotechnology is everything else apart from the basic applications. For example, the laws of biotechnology, the ethical areas of biotechnology, the intellectual property rights related to biotechnology, any paper being published in biotechnology, all these things they will be called as violet biotechnology. And then lastly, we have dark biotechnology, which is about the misuse of biotechnology. If somebody is using it as a bioweapon, if somebody is using it for bioterrorism, or anything that is a negative, going to have a negative impact, that is called as dark biotechnology. So in this chapter, we are going to discuss about the various aspects of biotechnology, and one by one, we will take up the various branches of biotechnology. We'll discuss about the various branches of biotechnology, and this is exactly what we are going to do in this chapter. To begin with, we are starting with the medical applications of biotechnology. Now, when it comes to the medical applications, this is the most important application of biotechnology, because today, if you see, you will find that medical application is where the most of the money in biotechnology flows. That, for example, if you look at the data for India, what you will find is that out of in every 100 rupees that is being spent on biotechnology, more than 70 rupees is being spent only on the medical applications of biotechnology. That too specifically in biopharma. We'll discuss about biopharma a little later. But just understand this, that how much importance we are giving to the medical applications of biotechnology, that most of the money that flows in biotechnology today, it flows in medical applications of biotechnology. More, I mean, out of every 100 rupees being spent, more than 70 rupees is being spent only on biotechnology, which is very important to understand that why exactly do we see that this is such an important branch of biotechnology. So medical applications wise, there are various medical applications, some of which what we'll discuss today, some of it will also discuss tomorrow. And when it comes to the medical applications, just understand this, that first, for example, we have something called as gene therapy. So gene therapy is the therapeutic delivery of nucleic acid into a patient's cell as a drug to treat a disease. And what we do is that we use genes to treat or prevent certain diseases. Now, in the context of gene therapy, just understand that what are we doing with gene therapy? That gene therapy is either about addition of a gene, it could be about addition of a missing gene, all right, or replacement, or let's just already removal of a diseased gene, or modification, maybe modification of a diseased gene, or it could also be about replacement of a diseased gene. So there are all these things that we can do with the help of gene therapy, and the gene therapy helps in this. So for example, what happens is that many a times when a disease occurs, that disease occurs because of some kind of problem. All right, some kind of problem. Uh, uh, let's say some gene is not working properly, so because of that some disease has occurred, or maybe there is some gene which is missing in our body, so that missing gene is causing some problem. So there are a lot of these kind of problems that could occur in a gene, and that is leading to some kind of disease or some kind of an issue in the body. So this is where gene therapy can be useful. In today's newspaper, the Hindu newspaper of today, there is one article regarding gene therapy. Can you tell me what article it is? There's one article in today's newspaper regarding gene therapy. And this is a trick question, because this will tell me who all are going through the news analysis on a daily basis and who all are not going through the news analysis daily. So, Prerna, you are going through the newspaper daily. Very good. Nobody else. I need at least one more answer. Hmm, that's not good. Go to the international page today. There is a small article on the top about gene therapy being used. Yeah, so here, chalo, you also have read the newspaper. So There is a news on the top of the newspaper on the international page today, and this is where the hearing of an 18 month old baby girl has been restored with the help of gene therapy. This is a first in the world that has been done. So that's why you have to understand that how important gene therapy becomes in this context, that we have been able to do all this with gene therapy today. So, and this is just one example from today's newspaper. Otherwise, there are n number of examples. Anyway, we are going to discuss all these examples as we move on with our discussion of this chapter. Then there is something called as gene genetic testing. Now, genetic testing is where we try to identify the changes in the chromosomes, genes, or proteins. And it is genetic testing that can confirm or rule out a suspected genetic condition or help in determining a person's chance of developing or passing on a genetic disorder. That what happens is that many a times we know that genetic diseases, they will be passed on from generation to generation, right? So in this context, we use genetic testing to test or find certain genes. So presence or absence of certain genes might indicate the presence or absence of a certain disease. And not only genetic diseases, many a times there are genetic markers, and these genetic markers will also help us in understanding whether there is a chance in the future also about development of a certain disease. For example, today there are so many of these full body checkups that are available. Now, when it comes to these full body checkups, you'll find that these full body checkups also tell you that they can tell you about whether there is a possibility of a future commencement of a certain disease in your body. How exactly do they do that? They test for certain genes. They test for the presence or absence of a certain gene. So if there is a certain gene which is present in the body, there is a chance that in the future a certain disease might develop in a person's body, that whether it's a pre-diabetic condition in somebody. So that can actually be found with the help of genetic testing. So that's why genetic testing in this context becomes very, very crucial. Then there is this very, very important segment in medical application about drug administration, where we use something called as biopharmaceutics, or the where we are making the biopharmaceutics. Two words, bio and pharmaceutics. Bio again related to the living organisms, that is the use of living organisms, and pharmaceutics. When we say pharmaceutics, what is it? Related to the medical science, or rather the medicines. So when we are making the use of living organisms in creating a certain medicine, it will be called as biopharmaceutics. So that's why biopharmaceutics is a very, very important branch of biotechnology. And that is where most of the money flows. Biopharma sector, the pharma sector, is where most of the money flows in this particular scenario. So that's why we have to understand that why biopharmaceutics becomes such an important segment, because it basically is about the interrelationship of the physical and the chemical properties of the drug, the dosage form, and the manner of drug administration on the rate and extent of drug administration. So this is where we have to understand that biopharmaceutics becomes very crucial, because it helps us understand that how physical and chemical properties of a certain drug responds to a certain medicine, or how our body responds to a certain medicine, uh, and the physical and the chemical properties of this particular medicine. So that's why it is a very important segment of research and development in the field of pharmaceutics. Now, one more aspect of the same has been pharmacokinetics. Now, what is pharmacokinetics? Pharmacokinetics basically is about, as you can again, you just break down the words, you have pharma and kinetics. Pharma, again related to medicines, kinetics. What is kinetics related to? Movement, right? So, when we are talking about movement of medicines, when we are looking at movement of medicines, this is what is called as pharmacokinetics, right? So what we call as pharmacokinetics is movement of medicines. What movement? Movement when you take a medicine, right? When you take the medicine, How much time does it take for the medicine to take an effect? How much time does it take to for it to start acting? How much time does it take for it to get out of the system? All these calculations, all these movements are tracked as a part of pharmacokinetics. Now, why is this movement important? Because you know that when it comes to each and every disease has its own mechanism in which it works. It has its own speed. So for example, there are certain diseases that develop perhaps within certain some hours, right? They develop in some hours. There are some diseases that take a couple of days. There are some diseases that take a couple of years to develop. For example, leprosy can take up to 5 years to develop, whereas something like a cholera can take just a couple of hours to develop. So, whatever medication you are taking, whatever medicine you are taking, that medicine has to be effective in that time period, before that time period. So, that's why pharmacokinetics becomes crucial, that we have to design a medicine according to the, you can say, the movement of the pathogen. The speed of the pathogen itself also matters. So, that's why pharmacokinetics. Apart from that, there is something else which is called as pharmacogenomics. So pharmacogenomics is a combination of genetics and pharmaceuticals, meaning that how exactly the genetic makeup of an individual responds to certain drugs, that how exactly certain individuals will respond to a drug depending on their genetic makeup. And that's why what we also see is that there are regional variations in what medicine is good and not good. For example, a medicine that is effective in India may not be effective in Europe, may not be effective in Africa. And you will come across these kind of news articles as well. That certain medicine that has been manufactured in India is not doing very well in Europe, or has been banned in Europe, or has not been effective in Africa. Why? Because the genetic makeup is different. And many a times the medicines are also associated with that genetic makeup. So that's why it becomes very crucial. And that's why we see that many a times it will also become very, very important part of the entire setup. And then there is virotherapy. Again, virotherapy, meaning it is the use of virus. Where we are making the use of virus. So when we make the use of virus for any kind of treatment, it is called as virotherapy. For example, there are so many antiviral drugs, there are so many vaccines where virus is used. So wherever we are making the use of virus, it will be called as virotherapy. And then lastly, there is recombinant insulin. What is insulin? Insulin is required by our body to remove the excess sugar from our body, right? To remove excess sugar from our body, we need what? We need insulin. Now what happens in diabetic patients is that the body stops making insulin, or it makes lesser insulin than usual. So then in that case, the body is not able to remove the excess sugar from our body. So that is what happens in case of diabetes. Then you might see that people might take insulin injections. Insulin injections might be prescribed to the diabetic patients because the body is not making insulin. So that also becomes a part of biotechnology itself, because this is where we see that the body has stopped making it, so artificially we are making it, and we are giving it to the diabetic patients. So these are some of the medical applications. We'll discuss about more medical applications. For example, we'll also discuss about stem cells. So stem cells are also related to red biotechnology. Similarly, we'll also discuss about the process of cloning. So cloning is also important in this context. So we'll discuss about all these things, and these are also medical applications that we are going to discuss. We'll also even discuss about DNA fingerprinting, for example. So DNA fingerprinting is also related to it. So we'll discuss about all these different aspects of biotechnology at a later stage. Tomorrow's, I mean, Monday's class is where we are going to discuss all that. So, so let's pause our class here. We'll start with agricultural applications of biotechnology on Monday. Until then, If you have any doubts, please let me know. Any questions if you have? What kind of vaccine is Covishield? Covishield, basically, we say that it is a live attenuated vaccine where we are saying that we are using a living organism or a living virus as a therapeutic agent, living virus, but completely inactivated, dormant virus. Leaderboard for today. This is the leaderboard. Oh, so there was only one question, and a lot of you have given the correct answer to your question. That's wonderful. All right. So, any other question if you have? So, previous slide. So, this is the previous slide. This is what we were discussing on the previous slide. Drug administration. So, drug administration is basically how we administer the drug, right? So, for example, the use of biotechnology in making medicines in the medical field. So, whatever we are not able to solve, if we are trying to solve with that, so all these things are actually a part of drug administration. How many questions come in biotechnology every year in the prelims? At least one, sometimes two or three. In the mains examination, every second year, perhaps we see that one question does come. Please explain what is genome. Genome, you can say, is the entire set of genes in the body. All the chromosomes together in an individual, they make up a genome. All right, that is what makes up the genome. I did not understand recombinant insulin. So insulin, just understand this, that insulin is something that our body needs to remove excess sugar from our body. All right. It is what we need to remove excess sugar from our body. And in diabetic patients, insulin is not being made by the body actively. All right. It's not being made by the body objectively. So that is basically what happens. And that's why we provide insulin with the help of these injections. Insulin injections are given. What is biopharmaceutics? Just break down the word biopharmaceutics. Bio is related to biology, pharmaceutics related to medicines. So when we are looking at how uh, the physical and the chemical properties of a medicine are affecting the biology of an individual, this is how, this is where we are looking at biopharmaceutics. Chromosomes page. Chromosomes page. This is the chromosomes page. Please provide all the uncredited PPTs from the first to the fifth class also. I think it's already available on the app. Please see it there. I'll again, if it is not, I'll again talk to the team and talk to them about this. Pharmacokinetics meaning. Again, just break down the words. Break down the words. Pharmacokinetics. Pharma is medicines. Kinetics is movement. So when we are tracking the movement of medicines in and out of the body, in and out of the system, that is what we call as pharmacokinetics. If the color of eyes changes with age, first it means that gene modified with time. Yes, it does happen. That genes also respond to the external environment, and many a times there are modifications that happen because of the external environments. So that's why that is something that does happen. So yes, it is possible that genes change over time. Brown biotechnology meaning. The meaning of brown biotechnology is that this is where we are making the use of biotechnology in agriculture, especially in the areas which are water stressed areas where rainfall is less or monsoon hasn't been that great. So all these where we try to use biotechnology to make plant varieties which can also adapt to low water conditions. But genes are not responsible for overtime change of eye color. See, eye color change is almost impossible over time. But I'm saying that genes do change. I'm saying that genes do modify. So, and many of the external conditions, they lead to genetic changes in an individual. For identification of parents, why only DNA test is performed, not nucleus or other organs? See, DNA is inside the nucleus. I don't understand this question. DNA is inside the nucleus, and DNA is required for the individual, all the individual characteristics, right? So all the characteristics that have gone from the parent to the child, they are all there in the DNA. That's why the DNA test will be done. Gray basically is related to environmental applications. Genes page, this is the genes page. Do genes also carry emotional traits? Actually, there have been a lot of research over time that have happened over this, that are the emotional responses also genetic in nature. There are some which have said that yes it is, there are some that have said no. So there still needs to be more studies on it, whether or not emotional traits are genetic in nature. For maternal family history, one can rely on mitochondrial DNA test. Yes, because mitochondrial DNA, when it comes to mitochondrial DNA, what we see is that mitochondrial DNA is something that is passed on from the mother to the child, not from the father to the child. So that's why maternal side, the same mitochondrial DNA are being carried. Yes, traits are carried by genes, emotional, physical, all that's correct. But yes, there have been a lot of research. If you look at some of the papers that have been published, they have tried to also understand that how many a times emotional responses change over time because of the external factors, and that lead to modifications over time as well. Hmm. So I think I've answered all the questions. If you have further questions, you are always welcome to ask them. Either you can bring it in the next class, either you can bring it in the next class, or you can ask it on the email as well if you want. So on over the weekend, please go back, revise everything. There are a lot of information that we have shared over the course of this week. So I hope that you go back, revise everything, and come back in the next class. So we'll meet back on Monday, and we'll resume from where we have left. We'll start with the agricultural applications of biotechnology first. Till then, thank you very much for being here. Good night. All the best.